Hello and welcome back to Data Analysis and Visualization. I'm Jovita Christie, and in this video, we are going to talk about some web-based applications for visualization design. In particular, we are going to talk about collaborative applications where teams can work together on a visualization and leave comments for each other, just like Google Drive. And we are going to be seeing IBM's Watson Analytics, which I am going to just show you the features of, and you can decide whether or not it's something that you would want to try out. And the second one is Plotly, for which I am going to create a Python code and show you how to use. So let's begin. In recent years, the World Wide Web has seen an impressive rise in the number of easy-to-use online tools available for data visualization and infographic design. So you no longer need to purchase, download, install, and maintain proprietary software packages to help you do this type of work. Instead, you can choose from a seemingly limitless number of open source web-based solutions available to help you achieve practically any visualization goal you're after. And in the next few videos, I will bring you up to speed on the best options available online for visualization design. So you're going to see many online applications for doing a visualization design. Now, what are collaborative platforms? Collaborative data visualization platforms are web-based platforms through which you can design data visualizations and then share those with other platform users to get their feedback on design or on the data insights conveyed. So it's just like Google Drive where people can collaborate and work on the same type of file. Collaborative data visualization platforms have been described as the YouTube of data visualization, but actually, these platforms are far more interactive than YouTube. Collaborative data visualization platforms are like a version of YouTube that lets you instantly copy and edit every video using your own software tools and then republish the video through your own social channels. Collaborative platforms are very efficient and effective for working in teams. Instead of having to email versions back and forth, or heaven forbid, learn a dedicated version control system like GitHub, you and your teammates can use the platform's sharing features to work on visualizations as a team, which is very good because you don't have to train employees anymore on how to use GitHub. You don't have to use emails to keep sending things back and forth to understand what's going on with the visualization, and then maintaining several copies of the visualization in your computer, because every time there are changes you make a new one. So this is something that's very easy to use, a collaborative platform that people can work on together. Even if you don't need or want to work with collaborators, collaborative platforms still have much to offer in the way of useful data analysis and visualization tools. These tools are often as powerful as, sometimes even more powerful than, comparable desktop packages. Just keep in mind that they often require users to publicly share their data and results so that others can view, modify, or use those results for their specific needs. So it's not as much as not much like Google Drive in this sense, because once you create your data, once you have created your visualization, they expect you to make it public so that other people can use it. That is why it is collaborative. And even if you don't want to work with a team and you're working all alone, you still get a lot of useful tools for analysis and visualization. So you should try out a collaborative platform. Now, the first platform that we are going to see is IBM's Watson Analytics. Watson Analytics is the first full-scale data science and analytics solution that's been made available as a 100% cloud-based offering. The application is available in a freemium version or on a paid subscription basis to match all levels of needs and requirements. So there is a freemium version, so probably you can have a sort of a trial of it for a certain period of time, and after which you have to go on a paid subscription. Although Watson Analytics is a full-scale data science accelerator, it also offers robust collaborative functionality so that users can share, interact, engage, and provide feedback on data insights that are generated. So it provides a very good platform for people to even communicate with each other while creating the visualizations. IBM's purpose for building Watson Analytics was to democratize the power of data science by offering a platform across which users of all skill levels and backgrounds can access, refine, discover, visualize, report, and collaborate upon data-driven insights. So this is something very important, and something that's it almost works like a question answer platform where people are collaborating and everything is publicly available, because only when you share it's going to increase. No matter whether you are an advanced data scientist that's looking for automation functionality to make your daily work easier, or if you're an entry-level data analyst that's looking for a way to generate deep data insights without learning to code things up yourself, Watson Analytics has something for everyone. The prerequisite skill level is simply that users know how to use a basic application like Microsoft Excel to do advanced deep analysis, for example, using pivot tables and VBA scripts, which are used. And if you have some basic skills with Excel, that's all you need to get started with IBM's Watson Analytics. If you're looking for a cloud-based, mobile-optimized collaborative platform that you can use to automate your data analysis, visualization, and reporting tasks, then Watson Analytics is the solution for you. And to get started, you need to go to the landing page and sign up for an account, and the link is right here if you would like to see it for yourself. Now I'm going to move on and show you Plotly with some Python code. Now I have some graphs that I have created in Plotly, and first I'm going to show you a choropleth. So for choropleth, this is the requirement. First, you need to install this, and to install, you can use your pip install in the same way as you would use if you were not using this collab, Google Colab. If you were doing it in your machine, then locally, then you'd just be doing pip install and name of the library. You must be knowing that because obviously you're familiar with Python if you are trying to learn data visualization. So these are the things, these are the requirements that need to be installed. And so you can see once you do that, you will just see a bunch of these things running, and it will show you that certain thing is right now installed, how many MBs are downloaded and everything. So I'm not going to run this again because it's already installed. And I would recommend that you pause the video and try to install these libraries. And once that's ready, now we are going to just import Plotly's figure factory, which is a part of Plotly, and we're just writing FF, which means it's wherever we reference figure factory, we're just going to refer FF and NumPy and pandas. And this is the CSV file that we are going to be using. And this CSV file is provided as a part of Plotly's datasets. So we are just going to use that. And it just it shows a couple of things about US. Different counties are there, and the year is there, the labor force is there, that these many people are capable of working, and how many of those people are employed and currently unemployed. So what is the percentage of unemployment? So that's basically what it is. And we want to plot this type of data. You don't really need to worry a lot about FIPS and stuff like that that's given here. Okay, because That is just something related to their country, some code or something given to each county or state. So don't worry about that if you don't get it. We are only thinking right now about these counties, the year, and the labor force that is currently available, and how many of those people are employed, how many are unemployed, and the unemployment rate. So now these state FIPS code and the county FIPS code, they are both sort of a zip code. They form a zip code. So if we combine the two, we can create a zip code. Now, what we are trying to do is, first of all, to create a zip code, there has to be a certain number of values, right? Certain number of digits required. So to fulfill that requirement, we are first applying this function. Okay, so we want these state FIPS code to be a 2-digit number. So if it is less than 10, then as you can see, it's going to be either 1, 2, 3, something of that sort. But we want it to be 0, 1. So if you want it to be 0, 1, then this is how you can do it. You can run this code and write down df sample state FIPS code. So we are just trying to read the FIPS code. And then we are going to apply to it this lambda function where we are using string.zfill. Zfill is, and when I write 2, then it's going to add an extra 0 if the original code is not fulfilling the length requirement. So that's what it is. And now when I do df sample.head, you can see that how the data has changed in this column. And in a similar way, I'm going to change it for the county code. And for county code, we want it to be 3-digit numbers. So if it is anything less than 100, then we'll just add 0, 0, 1 0 or 2 zeros before that. So this is what it looks like. And then we are defining our color scale. So now it's not necessary to define a color scale, but if you want your map or Coroplus to actually show a color scale that you want to use, then you should define a color scale. Otherwise, it's going to randomly probably assign a color scale. So now this is a color scale that's a sort of a blue color. So now these codes are just hexadecimal codes. They are available online. So if you just Google hexadecimal codes for blue color scale, you can get them. So what this shows is just 12 colors. I think there are 12 colors. 3, 6. Okay, there are. So these colors are actually different shades of blue. So you can just Google them. If you want to use some of these, you can use them as well. Now we are going to categorize all this into basically 12 categories because we have 12 different colors that we want to show. Now what this np.linspace does is that if you pass on some values, for example, you're passing on over here endpoints 1.0 to 12.0, and I want that divided into, from 1 to 12, I want that divided into certain number of parts, and then this is how you would do it. So you can see there is a 1, 1.7, 2.4, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are totally 16 parts for 16 colors. And what we basically want to do is divide into different ranges. So one range is from 1 to 1.73. So it means that if your employment rate falls between this area, if that county has an employment rate between 1 and 1. Unemployment rate between 1 and 1.7, then it will be colored with one of these particular colors. So maybe this color or this color, depending on which color you have put in this list, okay, in the order. And then we have 1 to 2. So if it is 1.7 to 2.4, then we want, again, we want another type of color. So we have divided the range of 1 to 12 into 15 or 16 different parts. And this is how you can do that, by writing linspace. Okay, so now what you have here, and that's why we are using here length. Just one more thing, that we are using length because we have certain number of colors and we want to fit those number of colors with this range that we have divided. Now, once that is ready, then we are just converting. This is just an example of how linspace works. So if you're passing, say, one starting value as 1, ending value as 3, and num equal to 5, which means you want to divide everything from 1 to 3 into 5 different intervals, then this is what you get. You get the first thing is 1, then you have 1.5, then 2, 2.5, and 3. You get 5 numbers that are between 1 and 3, with, of course, 1 and 3 included as well. So that is how it is. That's how we divided this whole thing. And then we are just going to convert our FIPS, which are right here, which we have FIPS code, right? We're just going to convert that into a list. So it's converted into a list, and we are converting the unemployment rate, which is this column, and of course this FIPS column. So FIPS column is, as you can see, a combination of the state FIPS code and the county FIPS code, which is combined using this line here. So these two are combined, stored as another column at the end of the table, which is FIPS. So now all the codes are 5 digits. So it's a zip code of 5 digits. So it's all equal and uniform. So you don't have to worry about that. And this is the unemployment rate percentage column. And those are the two columns that we are converting into lists over here. And then we're just ready to plot. So let me just show you what the plot looks like. You can see here, this is the plot. And these things that you see here, they are all the colors. And if you remember, we divided into different ranges. So 1.0 to 1.73, that is the lowest range of unemployment. So all the areas that are almost white over here, they are the lowest range of unemployment. So this is the lowest range of unemployment. And then as you proceed, areas which are really dark, like this area and this area, this is the map of US. So areas that are really blue, like really dark, those are the areas that are going beyond 12% of unemployment. So this is what your choropleth will look like. And to plot it, you just have to use this ff.createChoropleth function. And ff, remember, we imported that right here, figure factory. So that is imported here, which is what we are using now to plot. Okay, so create choropleth, and FIPS is equal to FIPS. Now this is actually something that is by default available because most of the things are very specific to the country, and FIPS is something that all the countries don't have but US has. And the function create choropleth of figure factory of Plotly provides you with this FIPS attribute by default. So it is considering US countries, it's already available. And values equal to values, because we already have our values ready. So this, when I say FIPS is equal to FIPS, then this is the FIPS. And values equal to values, so these values, that's what we are talking about. And scope is equal to USA because we only want to plot, we only have US data, and that's all we want to plot. So that's why. Color scale is equal to color scale. So we already have the color scale defined here. That's why it is equal to this. So we get our own colors of blue, shades of blue. And then we have show state data equal to false and show hover equal to true. So these are just some of the aspects, some attributes that if you want to keep, you can use. This is the aspect ratio, which is 2.9. Title is the title of this this graph. So USA by unemployment percentage. The legend title. So legend is this area that you see here. That is the legend. And we have even given a title to that. And we are not using any layout templates. Fig.show is going to show the figure, which is right here. So now that is how this whole plotting works in a choropleth, and it's very simple to do for this type of a choropleth. Next one we are going to try is a world choropleth. So instead of plotting something just for US, we are going to plot something for the entire world, and this is the data set we will be using. So I'll just show that to you now. Now this is a world choropleth. So instead of creating for just US, we are going to create it for the whole world. And here the country is given. We don't need to worry about everything. This this data that we have is a data of life expectancy of that country, which means what is the average age at which people die in that country. So that is life expectancy. And we also have a GDP percentage of that country. What is the GDP of that? Is the growth. I think it's the growth development. So what is that of the country? And those are the things that we are going to plot. So this is taken from Gapminder, as you can see. And it's only taken for the year 2007. That's the data we are going to plot. And this is just information about the data. What is the data type of all these columns and everything. That information is given here of the data frame. And this is how we are plotting the data. So you can see to plot the data, we are using plotly.express, which is another library available, and we are just using the choropleth function of it. We are passing Gapminder locations equal to ISO alpha because that's what's given here. These are the sort of short forms of these countries, like Afghanistan is AFG, and that is what we are passing here. And then we are going to do color equal to life expectancy. So we want to color based on the life expectancy, and when you hover over a country, you should get some data. So let's see what that looks like. Fig.show is going to show the figure. Now you see if I hover over a country, for example, I'm hovering over this area. It's Congo, Democratic Republic, I believe. So it shows its ISO, which is COD, the life expectancy, which is 46.462 over here. And if you go here, life expectancy Afghanistan is 43.828. And let's see a few more countries. This is India. India life expectancy is 64.698. Here you can see that the legend, which shows, now here we did not specifically show any colors. We did not select a color scale like we did in the previous figure. So this is going to give these colors assigned by the library itself. So we have India, which is right here, which is at 64.698. That is the life expectancy. And you can see why the color is this, because about 64 would lie in this range, and this is the color that would be given to that. So the areas that are yellow, they have a life expectancy which is over 80 years, like this area. Canada, which is having 80.653, US 78.242. So that's how it is working. China is 72.961. So that's how this diagram is working, and you can zoom in and out of it. If you zoom in and out, you can see certain areas more clearly. All right. And next we have this another choropleth, which is about agriculture. So what kind of agriculture is done in this particular area? That is what we are plotting. And once again, we are using GitHub's, from the GitHub repository, we are using Plotly. Plotly's data set, which is about 2011 US agricultural exports. So that's what it is. And I'm not going to explain to you everything given over here because you can understand that. And this is the diagram that we have created. When you hover over it, you can get some more details about, you know, how much agriculture is done in USD. And this is US agriculture exports by state, how much export was done. And you can see here that the color scale we have just mentioned reds. So when you do that, you will get all shades of red to show this scale that is given here. So that's very easy to do. You don't have to define your own color scale every time. So this is how you can create a choropleth in Plotly. There are some other types of diagrams as well that you can create in Plotly. One is a scatter plot. So this is an example of a scatter plot right here. So once again, we are using the same Gapminder. We are using the same data set we saw earlier in this right here, this data set. Okay, 2007, which was showing you the life expectancy and GDP and stuff. So it's the same type of data set of 2007. And you can see it when you hover over it, you can see more details about it, but it's a scatter plot because we are only plotting points. We are not coloring the entire area. So that's how you can do a scatter plot in this. And we can also see, this is another scatter plot. Okay, I'm not going to explain this to you, but these are the types of diagrams that you can create. And this is another scatter plot which shows, again, using Plotly's own data set about 2011 February US airport traffic. So what is the airport traffic in US? That is what this data over here shows. So if you hover over it, you can see which airport exactly it is. Okay, and it shows you how many arrivals are there, 9898 for Salt Lake City. This one is for Phoenix. This blue one right here, you can see all these airport names. So it's very easy. You can see the code that's written is not much, and you can have these types of diagrams by writing very little code. And this is something of a heat map, more or less. This is more or less a heat map. So it shows, it's a heat map for earthquakes that occurred in those areas. So the data taken is from this link from a CSV file about earthquakes. And wherever you can see it is the margin and mapbox style is created. And wherever you can see more area, more yellow area, that means there have been earthquakes over there with a greater intensity. The intensity is mentioned here. So that is how this data is plotted for different continents. In this case, this is the magnitude given. So latitude, longitude, this is the magnitude of the earthquake. And based on that, we are plotting the data. So that's what you can do with Plotly. It's a very powerful library to create all types of graphs, not just heat maps and choropleths. You can create simple bar charts and histograms and everything else with it. So I hope this was helpful to you, and I'll be back with the next video. So I'll see you there, and thank you for watching.